Alright, so I've got 3 more of my little custom boards here ready to go. I'm working right now on doing some 3D printing for some brackets. So we have a little hanging bracket that's going to go for the Nano. I've already gotten one of my brackets you can see here printed out for this guy. Those holes, those will all get punched out. I just wanted to make sure it actually fit before I, started punching out holes and everything else. And we're going to build a little piece across here in the middle. And it'll have space here on either side for the wires to go either way. And then we'll just have a little shelf for all of the custom drivers as we slowly replace all these little blue ones and get rid of them. We're also going to be putting in a capacitor between each of the bus bars here at 10K. So I also have brackets printing for those right now. We're going to have a capacitor here and a large capacitor there because, as you noticed in the previous videos, it's starting to get a little bit sluggish. So with that, we're going to go ahead and start working on all of our wiring, clean up some of this, but honestly not a whole lot because it's about as clean as it gets for right now. We're just working on keeping our wiring harnesses here together so that we have, like this for example, is a kicker with the switches and everything. The bumpers will look the exact same. And Alright, so I'm going to do a quick video on the pop bumper just because I feel like it's customary, and I actually literally did have the exact problems that were described to me by some of the other videos that I watched. So right here in the very middle, you can see this guy right here. This is the actual piece that moves the leaf switch right here to make contact and let it know that it's actually, hit the skirt and it needs to bump. And what happened is this particular part here was curved to the side a little bit, so that when, let me put my hand under the table here, so that when it actually is sitting here and triggering and trying to trigger it, it would just kind of scoot off to the side and not really push the leaf switch. And there's several videos out there that, again, they explain how that works, what happens and everything, but all we needed to do is just unscrew these bolts really quick, shift it over, I don't know, a degree, maybe a 2, and then go ahead and tighten them back down on top of there, and sure enough, it's working great now and everything looks great. Another thing that I noticed is that even though that this is a Home Depot or Lowe's half-inch where it's kind of missing a little bit of space, I did try to put in 2 washers. That's why some of these screws are a little wonky still. The screw holes are a little bit of an angle. And when I went ahead and put those washers into these, it was significantly too low in the play field still to actually meet up. So it's definitely more like a 1 washer job or none with these skirt style where it has the entire thing like this. If I had the other style where it just kind of goes through the play field and it doesn't have this huge bracket around it, it might have been a different story. But at the end of the day, I'm just really glad that I bought these. One other thing about the leaf switches is that these all came with flyback diodes attached to the lights, to the actual contactor, to everything like that. Lovely little flyback diodes. As you're noticing, they're not there because they're here in my hand. I clipped every one of them off because we're not going to be using the high voltage system to power those. We're just going to be using microcontrollers and separate wires. So that's going to be part of our task today, is to solder up all of the wires that I have and all the little connectors for logic stuff that's going to connect in the back. And they're going to get soldered onto these little posts here. And then, of course, as we're going through, we'll make nice wiring harnesses and make sure everything stays nice and even now that I've learned my lesson from the playfield cabinet. Alright, just a quick update. Here's the actual installation for the opto bracket right here. And then here's, of course, our actual one-way gates that I've put in now. They're pretty flimsy for PLA, but they do work. Pops open, bounce, bounce. And that's exactly what it's supposed to do. Now we get to the computing part. So this is the first video for computing that we'll have. We're just getting started with target switches and doing UART, because again, everything is going to come through the nanos. We'll have bumpers and slingshots that have these target switches attached to them, and then they'll communicate from the nano to the Teensy, and then the Teensy will control the lights, and then it will also send commands to the Pico to then send commands to a DF player to a speaker for outputs for sounds. So what I spent most of the time today doing is getting the actual UART protocols down so that they'll actually talk to each other from nano to Teensy. Teensy was the choice because it has 8 different ports in which it can do this. So we have this lovely example here. And so we're starting right here, and we're going to go ahead and use at least these ones here, and probably up to the number 5, I think is what we're going to go for now. Just to do that, it depends on how much we're going to do with the Picos and the soundboard. So for now, what I have is this one light here is wired up so that this light will go off, imitating the wiring harness for the one target switch hooked up here. These hybrid nanos will take D4 through D8 as target switches, optos, anything else that I really need. They're all packaged into one nice little function. So without further ado, target switch and light. From UART, nano to Teensy, and the light. And then just a quick look at some of that code that we've been doing here with sending the packets back and forth. We just have this sent for a command that is hit, and then the ID that's actually coming through. And then over here on the Arduino side, or the Teensy side, we're just using the basic Teensy developer to go through and just put in a basic loop, receive the packet, and then just do the digital writes for here. If we have time, we'll go ahead and get a little bit further deeper down. I do have a large Teensy header here that I've been kind of playing with the whole time. But like I said, just trying to stay organized and keep these things simple, since again, we're starting to incorporate multiple microcontrollers.